Hi, I'm Luis Carbajal, and I'm here to talk to you about something really exciting. You've been on a roller coaster, right? You wait in line, 10 minutes, 20 minutes, 2 hours sometimes. You've been to Magic Mountain. Even if you haven't, sometimes you have to wait a long time because everyone wants to get on a roller coaster. And we want to figure out why roller coasters are so exciting. So let's talk about energy. Energy is everywhere, right? There's the conservation of energy. That means, when I put a battery into a flashlight, the battery has chemical energy, a chemical potential energy, and it's turned into a radiant energy. It's turned into light. And we can see here that for our demonstration that energy is going to be the force or the work done by a force over a certain distance. Now, there's a force that works on all of us. It's pretty strong, but not too strong to where we can't get up. It's gravity. So we're going to be talking about the very special force of gravity applied to all of us. So energy, right, again, is force, which is mass times acceleration times a distance. The units for that would be joules, and that would be defined as kilograms times meters squared times over seconds squared. So let's look at our roller coaster. I built this one myself. You start at the very bottom and you climb. Now, why do we climb at the very start of a roller coaster? Well, we need energy to get somewhere. So we climb, it's click, 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 and you're at the very top of the roller coaster. You're high up. You're higher than anyone in the carnival, anyone at Disney World, and you can see it far. Now they stop there. Well, one, because it's terrifying, right? That's the thrill, right? You're about to go down, and once you fall down, you're going as fast as you can, and you'll hit the bottom. So you're going, and you drop, and you're going, and you hit the very bottom, and you're safe, of course, and you're going super fast at the bottom, and then you're going up and down and through some loop-de-loops, and Batman's coming in, whatever roller coaster you're on, it's very exciting. But what makes it exciting is the drop. So we'll go more into this drop. Here in our drop, we'll have two different kinds of energies that we're going to transfer to. We have the potential energy, which is defined here as mass times gravity times height. So you'll see here that the force of gravity is mass times gravity, and then the work that's done is over h, the height. And then we'll have the kinetic energy here, which is 1/2 mv squared. And you'll see here that it's just the velocity squared times mass. So again, we want to see that this is correct for our units. So we have kilograms times meters squared over seconds squared. We have a kilogram here, meters per second squared times meters, so that's meters squared times second squared. And here again, we're at your mass, which is your kilograms, and then velocity squared, m over s squared, so m squared over s squared. So we're perfectly fine with that. These two can be defined as energies. So let us know how fast we're going at the very bottom. We really want to know that. So we'll see that the sum of the energy of this system, which is the roller coaster, is always potential energy plus kinetic energy. Now, we're at the very height and at the very top and the very, very bottom of this roller coaster. So we'll make it easy, and we'll say that the first energy state up here, you'll notice the 1 is just your potential energy, and your second one at the very bottom is kinetic energy. So we'll see E1 is equal to E2. mgh is equal to 1/2 mv squared. Now let's work that out a bit, and we'll see at a certain height how fast we're going. So here we have potential energy again is equal to kinetic energy. Your mass times 9.8. 9.8? Yes, again, that is your acceleration due to gravity times blank, which is your height. What height would you like to do? 50 meters. How convenient, thank you. Is equal to 1/2 mv squared. So we'll see here that we have mass on both sides, so we can cross that out. Now we have 9.8 times 50 equals 1/2 v squared. That becomes 100. 9.8 times 100 is equal to v squared. And square root that. Luckily for me, I've already calculated that out for you. 31.3. So you're going 31.3 meters per second at the very, very bottom. So here, we're now going 31.3 miles per hour. Now, that might not seem fast because, you know, you've been in a car before, but when you're in a rail cart, that is very, very fast. And let us not forget that it only gets faster when you go higher. So, you know, next time you're in a roller coaster and you're like, which one do I want to go to? If you want to go to a more thrilling roller coaster, you'll go to the one with the very, very, very highest peak. Because once you get that drop, it's 2, maybe 3, 4 seconds of drop. Oh, that is the best time you're going to have. All right, well, thanks for joining me. I hope we can do this again sometime. If you have any more questions, leave a comment below. Thank you, and goodbye.